Hi, everyone. Welcome to another NLP Insider Live show, and thank you so much for joining us. We are here live every other week for 15 minutes to talk about everything NLP with industry leaders. I'm David Alby. I'm the CTO at John Snow Labs, and today I'm very excited to welcome Hoifung Poon, who is a Senior Director of Biomedical NLP at Microsoft Research and an affiliated professor at the University of Washington Medical School in Seattle. He leads Project Hanover, with the overarching goal of structuring medical data for precision medicine. Hoifung is also giving a keynote at the upcoming Healthcare NLP Summit on April 5th and 6th. Today he's here to share his insights and give a small preview of what you can look forward to. I'm so glad to have you with us today, Hoifung. Welcome.
Thanks a lot, David. Really excited to be here. I've been watching you guys in the Spark NLP space and really impressed by your work. And so good to, thanks for having me here.
Thank you for coming. It's a pleasure. So let's jump right in. You've been doing research at Microsoft for over 10 years now, and you currently lead the Biomedical NLP research team to advance machine learning for precision health. Can you tell us a bit more about precision health and how NLP applies for it?
Yeah, it's a really sort of like exciting time for us, right? In the NLP and the machine learning time for biomedicine. And if you look at the biomedicine and healthcare, really sort of like experiencing a confluence of actually really positive disruptions, right? So on one hand, you have all these technological advances that actually make it affordable to generate a lot of high resolution sensor data. And cancer genomics is really the poster child for it, right? So from cancer biology, we already know that tumor is mainly driven by the mutations. And so by actually sequencing the tumor genome, we are literally staring at the source code for the cancer, and we can potentially tailor the treatment down to the individual level, right? And in the meantime, you have sort of the rapid digitization of the medical records, right? That actually make it available for a lot of this like longitudinal detailed information from for patient trajectory from diagnosis to treatment and outcome. So if we can actually sort of like harness all this data to generate what's called the real world evidence, and we can potentially, for example, interrogate, like compare between like exceptional responder versus non-responder to some cancer treatment, right? And potentially figure out better companion diagnosis, how to distinguish them at priority, even coming up with candidate improvement actually for how can we actually do better for those non-responder. So all these are very exciting, but much of the healthcare and biomedicine is conducted in natural language, right? So and a lot of those relevant knowledge and patient information are actually sort of locked in, scattered in all this biomedical text, right? So every minute we are talking here, PubMed have 2 new papers. Every day there are 4,000 new papers. Every year there are over 1 million papers, right? Reading a single paper, pulling out some of the latest finding could easily take hours. In the same time, if you look at just the US alone, right, there are close to 2 million new cancer patients coming up every year, right? And each of the cancer patient may have up to hundreds of, medical notes like pathology report, radiology report, encounter notes, and all that, right? So that's actually where sort of like the current way to try to get those information is by manual abstraction, which is very hard, right? Like curating even basic information for a single cancer patient could take 2-3 hours, right? So that's clearly not scalable. And that's actually where NLP potentially hold the key to drastically accelerate this curation efficiency. And we could actually partake in actually hope to accelerate, precision medicine and actually bring a lot of the potential benefit into reality. So very exciting time.
Yeah, I definitely agree with you. Definitely exciting times, as you said, between the available medical data now that's all digitized, right, and the advances in NLP, and you say the immediate applications for oncology. Yes, it's a nice confluence of factors. Yep. So, what do you see as the main challenge when using NLP for precision medicine?
Yeah, that's an excellent question. So, if you look at NLP, right, it has really sort of make tons of progress in the past few decades, right? We have come a long way, but a lot of the focus had typically be on sort of like some of the general domains, right? Like newswire, the web, right? When you look at biomedicine, actually the text there is actually have very different characteristics, right? And that actually poses really a lot of additional open challenges. But biomed NLP traditionally have been a little bit sort of like underexplored, right? So, for example, like if you look at kind of like some of the machine reading, right, in general domain, right, information extraction, a lot of the focus tend to be, on some of the, for example, the celebrity facts and all that have really exhibit a lot of redundancies, right? Like, one news event could be reported in 1,000 places, right? But in biomedicine, actually, the most high value information actually tend to exhibit the least redundancy. So, for example, like the latest finding in yesterday's New England Journal of Medicine, probably that fact only appear in one place. And if you miss that, you might miss this really crucial hint that you might be able to apply to, for example, a cancer treatment, like you said, right? So then that actually forces us to kind of like combat head on some of the challenges, right? Like, for example, like majority of the information extraction work tend to focus on like let's say binary relation within single sentences. But when we look at a lot of biomedical space, we are basically compelled to basically focus on much more complex like relation, like for example, tumor with a specific gene mutation, whether it respond to a drug, and if so, in what kind of cancer type, right? What kind of empirical evidence. Such complex relation tend to span across sentences, sometimes even across documents, right? Like think about information like for cancer patient, like in multiple reports, right? Multiple notes. So that's kind of like one big challenge, is like we need to tackle a lot of those complex semantics. Now, obviously, we have lots of powerful tools in machine learning, but there are two challenges right there, right? One is like, because a lot of these more complex semantic understanding tasks and longer text spans and all that, some of the standard, for example, the neural architecture like LSTM, BERT, they may not be actually perform that well. So we need to sort of innovate on the neural architecture front to be able to accommodate those elaborate semantics and discourse structure. But also, like another big bottleneck for standard supervised learning is the annotating training data, right? Now, in biomedicine, we actually lost a very powerful tool of crowdsourcing, right? Imagine you ask your Tucker to say, help me interpret this genetic paper for me, or a Parstat CT scan for me. That would be quite challenging compared to labeling cats and dogs, right? So that's another sort of kind of like big machine learning challenge where it forces us to actually explore alternative paradigms.
Mm-hmm. Yes. Yeah, and I think for us, I can say we've seen the same challenges. First of all, yes, like one cancer patient easily would have more than 1,000 pages of documentation over even just a few months, right? And some patients are multiple years. And definitely, yes, getting annotated data where yes, you need medical doctors, right? You need people who are radiologists and pathologists and oncologists, and then even they disagree sometimes, right? For valid clinical reasons. Yeah, so it's definitely yes, but I would say we need that right interaction, right, between data scientists and medical doctors to make that progress. Absolutely. So you've been working on Project Hanover at Microsoft that addresses these challenges. Can you tell us what this project is all about?
Yeah, so the overarching goal in Project Hanover is really that we sort of aspire to advance biomedical NLP and machine learning to really sort of try to empower, to scale the structuring of medical data and ultimately empowering precision medicine, right? So one of the sort of like kind of like the distinct kind of approach for a lot of our work is that we grounded a lot of our research squarely in deep partnership with key stakeholders such as healthcare providers and clinical researchers. So in that way, we are basically get exposed to a lot of this real world scenario. And so we actually find that it's really exciting area because we was able to get into the real world kind of like problems to actually uncover a lot of the open challenges and and also, frankly, they open up exciting research opportunity to uncover a lot of the traditional underexplored area. So more specifically, like for example, on the NLP problem side, right? So we kind of like we have been focusing a lot on more complex, more sophisticated semantic, modeling, understanding tasks, right? For example, like extracting all this complex, relation, cross sentence, sometimes even cross document, right? And from a methodology point of view, that also motivates us to kind of like sort of like innovate on, for example, some of the neural architecture front, like how do we handle this kind of long range, text span, right? Like we have been exploring something in the multi scale representation learning, some of the modular supervision, modular neural network, some of the graph neural networks front, and then most importantly, we like exactly as you point out, right? Like you can't count on forcing doctors who are very expensive and very few of them, right? Very scarce resource to help me create, image and net scale kind of annotated data, right? That's really hard to do. So we have been focused almost exclusively on sort of like the alternative paradigm of self-supervised learning, where essentially it's like we try to leverage any of the free lunch, right? Like any available domain knowledge, linguistic knowledge, and any structured resource to try to essentially kind of like automatically create lots of noisy training data on the unlabeled text, right? And ultimately, exactly like you said, like a lot of this research, ultimately the goal is not to actually replace human. Actually, I think that's still very far away, right? And what we are hoping for is actually to attain sort of like human-computer symbiosis, right? So you have a giant haystack, let's say 4,000 people to read today, right? But most of the haystack actually doesn't even look remotely like the needle you're looking for, right? So
Yep.
that means like even sort of like noisily trained self-supervised machine reader can potentially quite reliably remove a lot of those haystacks. And now we will reduce that to a tiny set of candidate needles that the human, exactly as you alluded to, right, to start to do human in the loop interactive learning. So that way, like, you basically ensure the quality of the output, and you actually maximize the human expertise. And also they tend to be a lot happier because you take away the really boring, repetitive, the legwork. So yeah.
Yes, yeah, no, I agree with you. First of all, yes, if you take away all the boring stuff, people are much more likely to actually do it. Yes. Yeah, and the other thing I think, especially doctors and experts, they need to be able to specialize, because I think another thing I've seen, different doctors don't treat cancer the same way.
Exactly.
Right. So a lot of it, I mean, this is why you want second opinions on different approaches, right? People do not agree on what the correct thing is, so you need to work with people right on the approach that they believe in.
Yeah, to quickly sort of echo that point, right? So one thing we try to be very clear is to separate the machine reading problem, the NLP problem, like what is the text explicitly stating, versus some of the what we will call the reasoning problem, right? So sort of like there were sort of like the NLP problem, machine reading problem are relatively objectively easy to agree upon, right? Like, does this piece of text say something? But then if you try to elaborate beyond that, right, then exactly like I said, like two doctors may give you three opinions, right? So,
Yes.
so that part
Exactly. And they're all correct. Yes.
is harder. Yeah, exactly.
Yes. So you'll be talking about Project Hanover and more in your keynote in the upcoming Healthcare NLP Summit. What can the audience expect from your presentation?
Yeah. So first of all, I kind of want to sort of like I'm a sort of like a straight computer science person. I did my PhD in machine learning and NLP, but I sort of like stumbled upon this precision medicine. I really like biology and all along, and sort of stumbled upon this area and find it incredibly exciting and also super meaningful, right? So and I want to sort of like hopefully in the talk to sort of kind of share why this is such an important area, right? Like precision medicine, why it holds some of the potential key to potentially profoundly transform healthcare for the good, right? And also more crucially for all of the AI researchers and practitioners, I hope to show some of the concrete area where actually AI and specifically NLP and machine learning can contribute, right? And I also hope to also illustrate sort of like some of the real world kind of like already some of the current promising result, right?
Yeah, that I'm excited to see. So thank you again, Hoifung, for joining us today. Everyone, be sure to catch his excellent keynote, as well as over 30 more sessions from industry leaders focused on natural language processing, best practices, real-world case studies, challenges in applying deep learning and transfer learning in practice, as well as all the latest open source libraries, model, and transformers that you can use today at the upcoming Healthcare NLP Summit on April 5th and 6th. And we've dropped the link in the chat here, so be sure to go and register today. Thank you very much for joining us today, Hoifung. I greatly enjoyed this chat. I'm definitely looking forward to meeting in person as we discussed. Thank you.
Yeah, thanks a lot, David. Thanks again for having me, and let's definitely grab a coffee when the weather gets better.
Exactly. Thank you very much.
Okay.
Thanks, everyone.
Cool.
Bye-bye.
Bye.